Welcome you all to the video lecture on signals and systems. Today we are going to discuss about 2 marks on mathematical operation on continuous time and discrete time signals. So, some of the easy 2 marks problems in continuous time and discrete time signals we are going to discuss today. So, the first 2 mark is given is x of t, the value is t and it varies from 0 to 3, and we have to draw x of minus t and x of 2 minus t for the given signal. So, first of all we need to draw what is x of t. Okay. So, they have given the it varies from 0 to 3. So, 0 t value 0, 1, 2 and 3, this is what they have given, and they have given that x of t equal to t. So, when I substitute 0 at a t equal to 0, x of 0 is equal to 0, just substitute in the given equation, x of 0 is 0, at t is equal to 1, x of 1 is 1, at t is equal to 2, x of 2 is 2, at t is equal to 3, x of 3 is 3. So, using these things I can draw the given signal x of t. So, I need the amplitude 0, 1, 2, 3. So, 1, 2 and then 3. So, they have given that at 0 x of 0 is 0. So, here 0 at 0 x of 0 is 0, at 1 x of 1 is 1. So, here for 1 the amplitude is 1, at t is equal to 2, at t is equal to 2 the amplitude is 2. So, I have to put the dot here, at t is equal to 3 x of 3 is 3. So, since it is they have represented all the signal in terms of t, it is a continuous time signal. So, just join all the dots. Okay. So, this is my signal x of t. So, first I have to draw x of t, then I can determine the given question, that is they have asked x of minus t. X of minus t is nothing but time reversal operation. Okay. So, x of minus t. So, if I have minus symbol before t, it is time reversal operation, which is also called as time folding. So, we have to draw the time folding signal. Okay. So, whatever we have here in the right hand side, it will go to the left hand side. So, how will you draw? The amplitude remains same. Okay. Only time we have to change. So, 0 becomes 0, 1 becomes minus 1, 2 becomes minus 2, 3 becomes minus 3. Amplitude remains same. So, here at 0 amplitude is 0, here also at 0, at 1 the amplitude is 1, it will go to minus 1. So, at minus 1 the amplitude will be 1, at 2 the amplitude is 2, here at minus 2 I have to draw the amplitude 2. At 3 the amplitude is 3, it will go to minus 3. So, at minus 3 the amplitude becomes 3. Okay. So, now join all the dots. So, this is your time reversal signal, which is nothing but x of minus t. So, x axis is t, y axis is x of minus t. So, next they have asked x of 2 minus t. Okay. So, when I see the signal 2 minus t, I have this operation, this is nothing but minus t. Okay. Minus t is nothing but time reversal operation, time reversal. The next operation is shifting. So, this I am considering it as minus t plus 2. Okay. So, it is time shifting operation. So, we have to do 2 operation for this signal, one is reversal, another one is time shifting. So, already we have done with the time reversal operation. So, we can use this signal to produce the second signal, which is x of minus t plus 2, that is x of 2 minus t. So, just we have to shift your signal. So, for shifting your signal, for time shifting operation, whatever we have within the braces, the functional value we have to take as it is. What is the functional value? 2 minus t. Okay, it is nothing but minus t plus 2. Functional value I have to take in and equate it to 0. So, find out your t value. What is t? T is equal to just 2. So, I have to shift the x of minus t signal by the value 2. So, how your shifting will be? Minus 3 plus 2 is nothing but minus 1, minus 2 plus 2 becomes 0, minus 1 plus 2 become 1, 0 plus 2 will become 2. and your amplitude remains same. So, whatever the amplitude here I have to produce as it is. So, 1, 2 and 3. So, here the amplitude is 3. So, I have to start with that amplitude. So, I will have 3, 2, the next amplitude is 1, the next amplitude is 0. So, in that way I have to draw. So, just join all the dots. Okay. So, this is x of 2 minus t. So, we need to perform the reversal operation followed by time shifting. Second problem is given x of n equal to 1, 2, 3, minus 4 and 6, plot x of minus n minus 1. So, we need to draw this signal first of all, and it is a discrete time signal. Why? Because we have n and all the terms are given in sequence, and they did not give an n value. What is n range? They did not give n. So, it is considered that always the starting value, if they did not give arrow, it is nothing but the starting first value is nothing but n equal to 0 value. So, with that knowledge we can start drawing the diagram. So, it is n equal to 0, it is n equal to 1, it is n equal to 2, it is n equal to 3, and the last value is n equal to 4. So, we have to take all those values in x axis. So, 0, 1, 2, 3 and then 4. So, this is x of n, and whatever the amplitudes they have given, we have to mark the corresponding amplitudes. At n equal to 0, the amplitude is 1. So, you can have here. So, draw the stem since it is discrete time signal. At 1, n equal to 1, the amplitude is 2. At n equal to 2, the amplitude is 3. At n equal to 3, the amplitude is minus 4. At n equal to 4, the amplitude is 6. Okay. So, once you have drawn this, the question is x of minus n minus 1. So, as that of the previous problem, draw the reversal signal first, x of minus n, and then you can draw x of minus n minus 1. Okay. So, what is a reversal signal? Whatever we have in the right hand side will go to the left hand side, the left hand side values will go to the right hand side. So, here 0, 1, 2, 3, 4 I have. So, I have 0, minus 1, minus 2, minus 3. I will have minus 4 here, okay, and then the amplitude remains same. So, 1, 2, 3, 4, 5, 6 I will have. Similarly, the negative side minus 1, minus 2, minus 3 and then minus 4. So, at 0 the amplitude is 1, it remains same here also. At 1 the amplitude is 2, so it will go to minus 1. At 2 the amplitude is 3, it will go to minus 2. At 3 the amplitude is minus 4, it will go to minus 3. At 4 the amplitude is 6, it will go to minus 4. Okay. So, this is your reversal signal x of minus n, and finally, the last diagram I have to draw x of minus n minus 1. So, again the same way, whatever you have within the braces equate it to 0. So, minus n minus 1 equal to 0, n equal to minus 1. So, I have to left shift your values. I have to add this n equal to minus 1 with each and every instance of n. So, I will have the diagram as this. So, minus 4 minus 1 is nothing but minus 5, and minus 3 minus 1 is minus 4, next is minus 3, next is minus 2, okay, minus 1 minus 1 is minus 2, 0 minus 1 is minus 1. So, up to this I will have. The amplitude remains same, 1, 2, 3, 4, 5 and then 6. Negative side you have minus 1, minus 2, minus 3 and then minus 4. So, whatever you have here, just draw here also. Okay. Just a shifted diagram you have to draw. So, here at minus 4 I have amplitude minus 6, that will come at now at minus 5. Okay. So, first stem you draw correctly. At minus 5 the amplitude is 6. The next values you can write in a sequence. Next amplitude is minus 4, you can write at minus 4. Next amplitude is 3, that you can draw at minus 3. Next amplitude is 2, that you can draw at minus 2. Next amplitude is 1, that you can draw at minus 1. Okay. So, from the discussion we know that it is just a shifting operation. Okay. So, you have shifted your signal. So, this signal is nothing but x of minus n minus 1 and x axis is n. Okay. And the next problem, here we have to draw del of t minus 2, okay, and then u of t plus 2. First of all, we need to know what is del of t minus 2, and then we need to know what is u of t, only then we can draw your signal. Okay. So, how will you draw your del of t? So, the area at 0, right. So, the value at 0 it is 1. So, usually we will represent your del of t like this. Okay. So, once you have drawn that, then del of t minus 2 is nothing but, you have to shift this signal as usual, t minus 2 equal to 0, okay, t is equal to 2. So, 0 plus 2 is nothing but 2. So, you have to draw your amplitude at 2. Okay. So, this is del of t minus 2, this is your del of t, just shift your signal and draw your del of t minus 2. And then the next signal is u of t plus 2, first draw u of t. What is u of t? The value is 1, the value is 1 for t greater than or equal to 0. So, from 0 to infinity, for all the values the amplitude is 2, first draw u of t, which is unit step signal, and then now u of t plus 2 we have to draw as usual. Substitute t plus 2 equal to 0, t equal to minus 2. So, 0 plus minus 2 is nothing but minus 2, infinity minus 2 is nothing but infinity. Okay. So, you will have just a shifted signal, instead of starting from 0 you have to start from minus 2 and your signal will be like this. Okay. Just a time shifted signal. So, u of t plus 2 means left shifted signal you will get. And then so, next problem, they have given the signal x of t. Okay. We need to find out what is x of 2t plus 3. Okay. So, given is x of t, we need to draw x of 2t plus 3. First we need to do your shifting operation, that is x of t plus 3 we have to do, and then followed by x of 2t plus 3. Okay. So, time shifting operation first and followed by time scaling operation. Time scaling means you will multiply some constant with the t, okay, multiply or divide some constant with the t, that is time scaling operation, and this is your time shifting operation, some values you will add or subtract with the t. So, first let me draw your x of t plus 3. So, as usual what you have to do, first I need to substitute t plus 3 equal to 0, t is equal to minus 3. So, I will have your diagram, minus 1 minus 3 is nothing but minus 4, 0 minus 3 is minus 3, 1 minus 3 is minus 2 and 2 minus 3 is minus 1. Okay. So, you will as usual the same diagram you have to plot as it is. So, you will have a increasing slope, then the constant amplitude it get decreased like this. Okay. So, this is 1, this is 2 as usual, as how we have drawn here, the same type of diagram we have to draw, just a shifted signal we need to draw. Okay. And then x of 2t plus 3. So, it is time scaling operation, if some constant is multiplied with the t, it is time scaling operation. Time scaling operation means we have to equate 2t is equal to 1. So, t is equal to 1 by 2. So, now this 1 by 2 we need to multiply with each and every instance of t. So, previously whatever we have determined t, okay, we have added with each and every instant of t, but here we have to multiply with each and every instant of t. Okay, for time scaling operation we have to multiply. So, minus 4 into 1 by 2 is nothing but minus 2, minus 3 into 1 by 2 is minus 3 by 2, and next is minus 1, next is minus 1 by 2. Okay, just draw the same diagram as it is. Okay, here the amplitude remains same. So, it is x of 2t plus 3. Okay. So, the next 2 mark, so given is x of n, we need to draw x of n minus 3 and x of 1 minus n. So, take your x of n first, draw the diagram. So, here again there is no arrow, meaning that it is n equal to 0 value. Next is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, 9 instants you have the values. Okay. So, n equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. The amplitudes are 0, 1 and 2, minus 1 is there. Okay. So, 1, 2 and then minus 1. So, at 0 the amplitude is 0, at 1 the amplitude is 2, at 2 the amplitude is minus 1, at 3 amplitude is 0, at 4 the amplitude is 2, at 5 amplitude is 1, 6 amplitude is 1, 7 amplitude is 0, at 8 the amplitude is minus 1. Okay. So, since it is discrete time signal, we have to draw as a stem. And next is x of n minus 3. So, it is time shifting signal. Time shifting means substitute n minus 3 equal to 0. So, n is equal to 3. Just shift your signal and draw the diagram. So, 0 plus 3 is nothing but a 3 and so on. We have to add for each and every instance of n with a 3. So, 1 plus 3 is 4, next 5, 6, 7, 8, 9, 10, 11, because 8 plus 3 is 11. Up to this you have to draw and you have to shift and draw your amplitude. So, I have amplitudes what and all 1 and 2, here it is minus 1. Okay. So, first is 0, 0, 2, minus 1, 0, 2, 1, 1, 0, minus 1. And the next signal is x of 1 minus n. X of 1 minus n means first we need to reverse your signal. First draw x of minus n and then shifting operation we have to do. So, x of minus n, how you have to draw your x of minus n? Just reverse your signal. Okay. So, actually this is x of n, you have to reverse your signal. So, it will become 0, 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Okay. Just reverse your time values and then 1 and 2 amplitude is minus 1 here. Okay. So, reverse your values. At 0 whatever you have to draw as it is at 0, next value is 2, at that you have to draw at minus 1, next is minus 1, next is 0, next is 2, next is 1, next is 1, next is 0, next is minus 1. This is your reversal signal x of minus n. Now, finally, x of 1 minus n. So, equate 1 minus n equal to 0, n is equal to 1. Okay. So, just shift and draw your signal for one time. Your x of minus n I have to shift and draw for one time. So, minus 8 plus 1 is nothing but minus 7. So, I will start from minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1 and then 0 plus 1 is nothing but 1, up to this it will come, minus 1 plus 1 is 0, up to this it will come. Okay. So, this is x of 1 minus n and your amplitude remains same 1 and 2, here it is minus 1. Just shift and draw your signal. Okay. First amplitude is what? Minus 1, that you have to draw here. First you have to start with minus 1, then next amplitude is 0, next is 1 1, draw 1 1, next is 2, next is 0, next is minus 1, next is 2 and 0, 2 followed by 0. Okay. So, this is x of 1 minus n. So, the next 2 mark is del of n equal to u of n minus u of n minus 1. Okay, so we have to prove that this term is nothing but this. Okay, so first of all, let me take your right hand side, draw your u of n, and again it is a discrete time signal. What is u of n? U of n is equal to 1 for n greater than or equal to 0, it is 0 for n less than 0. Okay, so you will have amplitudes from 0 to infinity and it will be going on like this. Okay, so this is u of n. It will be going on, continuing, it will be going on up to infinity. Okay, n value also it goes up to infinity. Okay, so what is u of n minus 1? It is time shifting operation. So, n minus 1 equal to 0, n equal to 1, add 1 with each and every instance of n. So, what happens? 0 plus 1 is 1, 2, next 2 plus 1 is 3, 3 plus 1 is 4 and it goes on. Okay. So, instead of starting from 0, I have to start from 1. Infinity plus 1 is again infinity. So, it will be going on up to your infinity. Okay. So, this is u of n minus 1. So, subtract. Now, what is the operation? We have subtract u of n minus u of n minus 1. Subtract both the signal. Here 1 at a 0, you have 1 here. Okay. Here I do not have any signal. Okay. So, here I have amplitude 1 here. Okay, 1 here, 1 amplitude is there. Okay. But here there is no amplitude, it is 0. So, 1 minus 0 is nothing but 1, okay, at 0. At 1, at 1, 2, 3, 4, all those things, here also 1, here also 1. So, 1 minus 1 becomes 0. So, for all other values it becomes 0, okay, it will be continuing. So, this is looking like that of your del of n signal. The value exists only at 0, the amplitude is 1. So, this is nothing but del of n. Okay, so this is what the proof they have asked. So, they have given u of n and u of n minus 1, subtract both the things, it is looking like your del of n. So, that is the proof. So, therefore, we can say del of n is equal to u of n minus u of n minus 1. So, next is they have given pi of t is equal to 1 for minus 1 by 2 to 1 by 2 and equal to 0 otherwise. Okay. So, first let me draw phi of t, it is nothing but your rectangular pulse signal. They have given that amplitude is 1 for minus 1 by 2 to 1 by 2. This is pi of t. So, we need to draw pi of 2t plus 3. So, first I need to do your time shifting operation. First I have to draw pi of t plus 3. So, t plus 3 equal to 0, t is equal to minus 3. Okay. So, I need to add minus 3 with each and every instance of t. So, minus 1 by 2 minus 3 is nothing but minus 7 by 2. Okay. So, I have this value as minus 7 by 2, this minus, yeah, this is minus 3 and then 1 by 2 minus 3, it is minus 5 by 2. Okay. So, instead of drawing like this, I can shift all your values. Okay. So, first one is minus 7 by 2, next is minus 3, next is minus 5 by 2. Okay. So, I will have amplitude just shifted signal like this. So, this is pi of t plus 3. Okay. And then pi of 2t plus 3 is nothing but what I have to do, just it is time scaling operation. Time scaling operation means 2t is equal to 1, t is equal to 1 by 2. So, I have to multiply with each and every instance 1 by 2. So, finally, I can draw pi of 2t plus 3 as just multiply each and every instance by 1 by 2. So, it will become minus 7 by 4 and then minus 3 by 2 and then this is minus 5 by 4. Okay. Your amplitude remains same 1. Okay. So, this is your pi of 2t plus 3. And the last 2 marks. So, represent the following signal in terms of unit step function. Okay. So, previously they have given equation, you need to draw the diagram. Here the diagram has been given, we need to represent it in the equation. Okay. So, first of all, when seeing your diagram, how I can represent it. Okay. So, first it is looking like unit step signal. So, first draw a unit step signal. Okay. U of t, u of t is 1. Okay. It is for 0 to infinity. So, draw your signal u of t. Next, again they have stabbed your signal from 3. So, let me draw u of t minus 3. What is u of t minus 3? At from 3 to infinity the amplitude exists. It is nothing but u of t minus 3. Okay. Now, subtract this signal and this signal. So, you will get the amplitude 0 to 3 as 1. So, this is nothing but u of t minus u of t minus 3. Okay. So, first draw the amplitude which is 1 for 0 to infinity, and then since we are getting the signal which is stabbed at 3, I am drawing u of t minus 3. So, both I can subtract. Okay, u of t minus u of t minus 3 is nothing but this. Okay. So, I can represent, finally I can represent x of t is equal to u of t minus u of t minus 3. Okay. Thank you students, thanks for watching.